and welcome to another GCSE revision video, and in this video we're going to be looking at algebraic fractions. In this video we're going to be looking at simplifying algebraic fractions. Now we can simplify algebraic fractions in just the same way that we simplify numerical fractions. Let's take for example the fraction 12 over 24. So our first job when we're simplifying the fraction is to break both the numerator and the denominator down into their prime factors. That is to say, we factorise the numerator until we can't factorise it anymore, and we factorise the denominator until we can't factorise it anymore. Once we've broken down the numerator and denominator into their prime factors, we can then go ahead and cancel out any common factors. Once we've cancelled out the common factors, it's a simple matter to figure out what the numerator and denominator are in their simplest form. Except, of course, when the denominator is 0, in which case the fraction is going to be undefined. When we simplify algebraic fractions, we do exactly the same thing. Our first job, of course, is to make sure that the denominator is not going to be 0, so we need to stipulate that the x value is not going to be something that will make the denominator 0. So just like with numerical fractions, our next job is to split the numerator and denominator into their prime factors, that is to say to factorise them until we can't factorise them anymore. We can then cancel out the common factors from the numerator and denominator, resulting in a simplified fraction. And of course by now the brackets are wholly unnecessary. Okay, well, so much for the theory. Let's have a go at putting that into practice. Let's pick something like x squared plus 2x minus 15 all over x squared plus 10x plus 25. Now, when we put a quadratic equation or any kind of algebraic equation or expression on the denominator, we must try to find what will make that denominator equal to 0 so that we can say that x does not equal that thing. Otherwise, the whole fraction is undefined. So let's first of all try and find the roots of this expression, that is to say the zeros of the expression, or that is to say what values for x will make this expression equal to 0. So let's start by factorising it. So we've got x squared plus 10x plus 25. So we're looking for two numbers that will multiply together to give 25 and add together to give 10. Well, that's just 5 times 5 is 25 and 5 plus 5 is 10. So that actually means that this is a perfect square because our factors are x plus 5 into x plus 5. So we've got x plus 5 squared. So x plus 5 squared is going to be 0 when x is negative 5. So we need to stipulate that x is not equal to negative 5. Okay, so that being done, and we've got our denominator, let's factorise our numerator. So we're looking for two numbers that will multiply together to give negative 15 and add together to give positive 2. Well, that looks to me like 3 times 5 is 15, and if the 3 was negative and the 2 was positive, then you've got, the 5 was positive, then you've got negative 3 plus positive 5, which is positive 2. So we've got x minus 3 into x plus 5. Just let's expand that out in our heads quickly. That's x squared minus 3x plus 5x minus 15, and the minus 3x and plus 5x is going to be plus 2x, so that is correct. Okay, so what have we got in common? Well, we've got an x plus 5 in common, so we can cancel the x plus 5. with one of the x plus 5's that make this a square. So this simplifies to x minus 3 over x plus 5. And that's all there is to it. Okay, why don't you have a go at practicing some of those examples for yourself. I'd like to wish you all the best with your revision and all the best with your exams, and I'll see you in another video.